Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge. So basically the problem is jump game 2. We have an array of length n, and you are initially at position 0, and you can jump by at most nums of I forward, and the goal is to return the minimum number of jumps to reach the last position, basically. And we are guaranteed that we will be able to reach it. So for example here, we have 2, so we start at index 0, 2, that means we can jump either 1 or we can jump 2, okay? And then at 3, that means we can either jump here, here, or here, because 3, to reach the last one. So you can see the optimal one is to just go from 2 to 3, and then from 3 to 4. So that's just 2 jumps. So that's the minimum. So that's the idea. Now, nums is 1000, can be the values can go up to 1000, and the length can be up to 10 to the power of 4. So that already tells you that the brute force solution won't work, because it would be O of n by the maximum number of the value of nums, and so that would be 10 to the power of 7. So that probably won't work. Okay, so let's see how we can solve it. Okay, so let's see something here. So what we want to do basically is we want to be able to go from this one here, right? And then from 2, we can do either here or here. From 3, we can go either here or here or here. And what we want to do is the minimum number of jumps to reach the end. So sort of if we reword it, what we want is the shortest path, right, to the end, right? And by shortest path here is just minimum number of jumps. And you can see something interesting here is, if you think a little bit of this differently, what if you think about the numbers, the positions here as nodes, right? Then what would be the neighbors? What would be the edges? Then the edges would be just all the numbers that you can, all the indices that you can jump to from that number. So for example, for this position 0, let me put the position values. So this would be 0, 1, 2, 3, 4. So from position 0, for example, you can reach position 1 and position 2, because that's the allowed jumps you can do, right? From position 3, you can jump to position 2, position 3, position 4, right? So if we sort of write this in as a graph, then we have position 0. You can jump to the edge value is 2, so we can jump to position 1. You can jump to position 2, right? Okay. And then for position 1, you can jump to position 2, right? So you can jump to position 2, or you can jump to position 3, and you can jump to position 4, right? And of course, this is sort of directed. Okay. And so what we are looking for actually is just the shortest path from 0 to 4 to the end. So we are looking for shortest path from 0 to the end, which is 4. And so the shortest path in this case here is just going from 0 to 1, and then from 1 to 4, because the path here is just 2. If you try any other path, let's say go from 0 to 2, then you can't reach 4. If you try from 0 to maybe 3, you can't reach 4, right? So in this specific case, it happened that the only viable path is this one. Let's see if there is another path. I don't see it, right? But technically, you could do from 3 to 1. Yeah. Sorry, yeah, I didn't do all the paths. I just did 2. So basically, if we do the other paths, from 1, you can go to here, you can go to 2. So let's actually draw that. So from 1, you can go to, sorry, from 2, you can go to 3. So from 2, you can go to 3. And then the other path, let's just do it for all of them. From 1, you can go to 4. So from 1, we can go to 4. We already have that. From 3, we can go to 4. So from 3, we can go to 4 like this. And then from 1, we can go to 2. We already, do we have that? Yes. Okay. So is there another path? Well, we could take 0 to 2, 2 to 3, and 3 to 4, but then the path there is 3. The length there is 3. And so the shortest path is actually this one from 0 to 1 and then 1 to 4. Okay, we can also take from 0 to 1, 1 to 3, and 3 to 4. Right? So you can see there are actually multiple paths if we do all the nodes. Okay, and so already to find the shortest path in a graph, right? So here basically the nodes are the vertices. So nodes are the indices, and then the edges is just all reachable nodes based on with the jumps values, right? And so here shortest path to an end can be found with BFS really easily, right? So we just apply normal BFS with visited set and the queue and all of that, and once we reach this, the number of jumps that we have would be the right answer, right? So how do we do this? So let me apply it here. So basically for our queue in BFS, we would need the index because that's the node, and the jumps because that's what we want to return at each time, right? And we can just apply BFS and then at the end return the answer. So let's that we don't need to actually build the graph like with a graph node and edges. We can do it implicitly. Just we can for each index we will go from the index plus 1 to the index plus the number value, right? And that will simulate the neighbors for us. We don't need to actually construct the graph. We can do it implicitly. Okay, so let's do our BFS solution. So first we just need something to get the number of the array. In BFS, we need a queue, a DQ, right? So that we can add to the end and pop from the front. And we said in our BFS, we are going to put the index because that's the node. And then we are going to put the number of jumps so far, right? So basically it's going to be index and jumps so far. And this is basically index is just the node, right? And now we are going to do while queue. And we also need a visited set so that we don't visit a node multiple times. And in our queue, we are going to pop from the front and get both the index and the jumps so far, right? And we just check if we reached our destination. And our destination is the end. That's normal BFS, shortest path. You check if you reached the destination. If we did, then we know this is the shortest one because it's the first one we arrived at. Right? Because BFS goes level by level, the first one we arrive at is the shortest path, right? And so here we want to go through the neighbors, and the neighbors of this index is everything that is reachable from it, right? And so it's from index plus 1, right? And all the way to index plus the value in the number index plus 1. This is just for Python to be able to get to this exact value, right? And so these are all those reachable from it. So nodes reachable from index, right? Those are all those that you can jump to from this index. And now here we just want to make sure first that we didn't jump outside. So let's say you are at 4 in the before last position, and then if you add 2 or 3, you will jump outside of the array. So we want to safeguard against that. And we want to make sure that we don't visit a set that we have visited before, right? This is just normal BFS. And again, normal BFS is to add to the queue. So we add the neighbor because it's valid. And we want to add to the visited set as well. Okay, so that we don't visit it again because we just added it to the queue. We can consider it visited. But here we want to add 2 things actually. Remember the queue contains the index and the jump so far. So the jump so far is the jump to reach index, but we jump it from index to j, so we want to increment by 1 here. Okay, and at the end, if we never were able to reach the end of the end of the array, we can return -1. Of course, this problem guarantees that we won't get this, but we just safeguard against it regardless here. So this is pretty straightforward BFS actually. The only thing different is that we do the neighbors implicitly, right? So if we run this, submit, it should work. And this passes, right? There is definitely an O of 1 solution. I think there are other videos that do it, so I won't explain them here, but I think this is a lot more easier to understand. And I think the idea here is pretty clever because you don't usually think of an array just a problem on an array, you don't usually think of it in terms of BFS. But the fact that if we think about it in BFS terms, we are able to solve it easily, I think is a pretty useful tool. So that's it for today. Please like and subscribe, and see you on the next one. Bye.